the agenda for today is more focusing on, what it takes to build a best practice SaaS solution on AWS, because we keep hearing from people that they want to know the general patterns that are available, right? To see how to build isolation, or for that matter, multi-tenancy, or even address identity. So what we thought is, instead of going deep dive into a certain architecture with EKS or serverless, what we would do is we would lay down the landscape to you with various SaaS patterns so that you can identify, how it fits your environment, how would they influence your solutions, and then, what it takes to compose an architecture that would meet your business needs. And at the end, we see how Showpad is doing the same with using these patterns and design principles to achieve their business goals, right? So to moving on, let's take a step back from here and see the kind of mindset that we need to adopt. When we talk about SaaS solutions, or we try to build SaaS solutions, right? Because the general trend that we see is, looking at SaaS from a very architectural perspective. But if you think it's more on the business discussion first, because when we talk to our customers, we really want to know what they want to achieve in their business, what are their business goals, so that the architecture that we then build together is highly influenced on those business parameters, right? So SaaS, if you look, it's more on the business model, and it's all about agility. Because organizations moving to SaaS, they really want to innovate quickly. They want to, react, respond to their, they want to react, respond, and, release new features to their customers at a very rapid pace. So they're really looking for architectures that would enable them, to add on a lot of tons of users, reach out to new segments, new growth, and for that matter, of course, operational efficiencies, right? Because when you add a ton of users, you don't want to add a ton of new tools or operational overhead for that matter. And then when all this goodness of your product is released on a subscription model, you actually get to see a predictive stream of, your business value or the recurring revenue for your business. And hence, if you see, that's why organizations are looking for prescriptive guidance, so that they want to make sure that the workloads they are, running adhere to these architectural best practices to get all these goodness together. And on similar context, this is like a buzzword that has been, coming up. That's the blueprint of SaaS. But in reality, there is no blueprint for SaaS as such. There's no architecture that we can give you and, call it the best practice architecture, or, there's no engine that you can run your code through and get the SaaS solution out of it. So instead, we will have to take a look on the whole landscape, explore all the patterns, and then see what it actually fits our environment and our business needs. So moving on here, we have laid down the whole landscape for you with all the pieces of the SaaS puzzle together. So if you see, that's the management group. So this is a single pane of glass for your metrics and analytics that would help you actually to analyze what are the trends and activities of your tenants, your billing constructs, how do you want to provision your environment, right? And then comes the application space that actually holds your multi-tenant application. How do you establish multi-tenancy, or how do you go about isolation? How do you actually partition your data here? Also the facts that how do you want to establish your tenants here? Do you want to go for silos or shared architecture? And last, how do we actually establish tenancy in our SaaS application? This is really crucial, because this is the point where we want to know, how does the onboarding process looks like, or how do we even cater to authorization and authentication for our system, right? So the key takeaway from here is we have all the pieces here, but we need to explore what fits our needs, to achieve our business goals. Moving a level up from here, if you see, the SaaS architecture is basically having two domains. One is the control plane, which will have all the horizontal services, like the metrics, onboarding, billing, identity. And this is basically the management and operational experience for your whole multi-tenant application. And it's good to mention here that the control plane itself is not a multi-tenant environment. The next part to this is the application plane that actually hosts your multi-tenant application, your isolation strategy, your data partitioning strategy. And it's very important to know that if your architecture is not having the control plane, then it's really not a SaaS service. You might be having a very good multi-tenant application running, but it's missing out on the goodness of the SaaS service that it can bring to your table to support your business, So before we deep dive into a few of those patterns that we discussed, these are the few principles that we would really like you to take away from this session. So one, that's the SaaS environment and the technology beneath it is highly influenced by the agility, innovation, or the competitive needs of your business. And today, if you want to decompose your whole system into a service model, your decomposition strategy should take into account about the isolation strategy or the tenant tiering strategy or even the multi-tenant load. And the very crucial thing is, if you want success for your product, security is key, right? So you'll have to make sure the tenant resources are well protected from cross-tenant access. And their authentication and authorization becomes key to it. Because that's the place where you won't find out, how you bind your user identity with the tenant identity. And then your SaaS teams would have to heavily invest on metrics instrumentation, because that's the place that would actually give you the metrics and analytics to know what is the kind of cost or load on your system, what are the bottlenecks your tenants are facing, or for that matter, which are the features being heavily used by your tenants, right? So it becomes a crucial part. And then last but not the least, agility being really important for SaaS, onboarding is key to it. So you would really need to have an automated, frictionless onboarding for your new tenants to join your system. So before we move into a few details on the SaaS patterns, I would really like to invite Vincent to take you through. Thank you.
Okay, thank you, Roma. Is my mic on? Okay, yeah, I can hear myself. Okay, thank you, Roma, for this introduction. So I would like to dive into a couple of patterns and practices related to tenant isolation. And this is mainly focused around the application plane of your SaaS service. But before I actually dive in, I want to put some terminology in place that you're going to hear a lot in this talk. So first, actually, what I want to talk is about a silo. A silo is actually where resources are deployed dedicated to an individual tenant. So meaning that tenants get their own infrastructure deployed for the application. It doesn't always mean the entire stack. It can also be pieces of it. But it's good to know that it's actually per tenant base. At the other end of the spectrum, we got a pool. And a pool is actually referred as sharing of infrastructure for the resources. And this is actually the more classical understanding that we know from multi-tenant applications. And just to put it out there, there's something in between called bridge. Usually you will end up in a mixture. So some services will be shared in a pool, and some of them will be actually isolated, deployed in a silo. So let's take a look at what actually some drivers of why you want to do isolation. So the first one is actually about tiering. With tiering, you can actually provide certain pieces of functionality to different pools of tenants into your system. For instance, you can have a basic, a standard, or an enterprise tier, where you actually have part of your functionality provided to your customers in the basic, or that you want to provide 24/7 support, or maybe in high available environment, or single sign-on within an enterprise tier. And isolation can actually help you with that, defining those tiers. When actually your SaaS service is growing and you get more customers onto your platform, you actually also see that customers are using the platform differently, and some of them are using it more than others. And for those, actually, you get the concept of a noisy neighbor. So those are like tenants that are on your system, that are stressing the system, and it impacts the experience of your other customers. So good isolation practices can actually help reducing those noisy neighbor effects. Some customers actually have requirements around compliance, meaning that they don't want to store data or process data in a shared environment, and isolation is a way to actually comply to those compliance requirements. Also, not all applications are designed to be multi-tenant, especially when they come from a legacy system. So isolation can actually help you to still deliver those type of services in a SaaS type of business model. And in the end, it also brings you opportunities. So you can actually say to certain customers, hey, I can make an isolated environment for you, a bit like the tiering that I said before. So let's take a look at some tenancy models that you have in your stack. So at first, in the compute part, we have our service isolation models. And you can actually deploy services in a silo. So if you see tenant 1 and 2, they actually have their own set of services deployed for their own application. But on the other hand, the other tenants, they can also have a set service deployed, which is shared with each other, so in a pooled model. Just as important in your stack as the compute and the service part is the storage part. So you can have like a silo deployment of your storage, meaning that each tenant will actually have their own database provisioned for them, which gives you a lot of possibilities. For instance, that they have their own schema if you want. So you can also provide some customization in those regards. But it also comes with some challenges, because if your SaaS service grows and you go at scale with thousands of tenants, you also have thousands of databases to actually maintain. So backing up, schema evolvement, those are really challenges that you get there. So for those, actually, you also have a pooled storage approach, where actually your tenants are stored together in one database, and you distinct them with a tenant key. And in this way, actually, it makes it easier to manage those type of storages. The only thing you have to be careful of is actually querying the tenant data. You really need to do that right with the tenant key, because you don't want to end up in a situation where you're querying cross tenants and one tenant can see other tenants' data. So it's not always, if you have your application, that it's only just pooled or if it's just siloed. You can do a mix of match, and you really have to look at the services that you're going to deploy, which type of deployment model you're going to choose. For instance, you can have a service like the order service over here, which is siloed compute. So for certain requirements, maybe there is some customization in play that you want to do that. But you have actually with a pooled storage. But that service is actually talking with another service, the product service, which is both in a pooled model deployed. So you have a compute which is pooled, plus the storage is compute as well. And maybe even downstream from that, you have the invoice service, where the invoice service is actually pooled deployed, but you want to have dedicated databases for your tenants. So actually that one has a silo deployment. And usually with event-driven applications in the case, you have something called queues. And with queues, you can actually create a queue per tenant. So meaning that you can guarantee in certain throughput towards those tenants in terms of messaging that they're sending out. But that doesn't mean that you always have to do like a silo deployment for those tenants for consuming those queues. You can actually also use a queued compute and a pooled storage. So like I said, you really have to choose with each service how you're going to, either you go for a pool or an isolated siloed deployment. And it doesn't really matter from a tenant perspective, because a tenant will always want to see a siloed approach. They don't want to see have the notion that they are deployed within a pool with other tenants, and especially not displayed to them. So from a security perspective, it's always siloed. So let's see how we can actually use this in a tiering situation. So in this example, we have tenant 1 and 2, and they go to your SaaS solution, and they subscribe them on the basic tier. And the basic tier is actually a pool deployment, meaning that tenant 1 and 2 actually sharing the same infrastructure, and that they are in the same deployment. And tenant 3 actually goes to the subscription page, also select basic tier. And the provisioning engine actually makes sure that that tenant is also part of that pool which has already got deployed. But maybe for some of your tenants, you also have a premium tier. And the premium tier is actually siloed because they want to have certain features or they're part of their compliance requirements. And so for those tenants, there is a dedicated piece of infrastructure deployed as soon as they select their premium tier in the registration. And tenant 5 also actually selects the premium tier. And actually the SaaS application will deploy that in a siloed model so that it runs its own infrastructure. So if we look at these patterns, let's now see how that isolation works in various like landscapes and architectures. And there are a couple of architectures that we can provide for you to actually kickstart your journey into SaaS. So first one I want to share is the SaaS factory for Amazon EKS. So if you're maybe using a microservice type of environment deployed on containers, we have Amazon EKS, which is our Kubernetes offering. And with SaaS Factory for EKS, it's hosted on GitHub. You can actually download the code. You can contribute back to that if you want. And what it actually deploys for you is 3 front-end applications. So one is a landing page with a sign-up form for the application. One is an example application itself. Of course, that will be changed with your SaaS application that you have. It uses user management using Amazon Cognito. And it also deploys an admin console for you. And actually, those front-end applications are talking to APIs hosted from a Kubernetes cluster. And the Kubernetes cluster has a control plane deployed with a service for registration, with a service for user management, talking to Cognito. And it also has a tenant store, so that you always know which tenants are onboarded, in which state they are. And it also comes with an example of an application plane. So let's take a look on how a SaaS application can be architected on EKS. So in this example, you will see the Kubernetes cluster has the control plane deployed. It has a registration part, it has a tenant part and provisioning part. And there's already one tenant in there, and it's isolated, deployed within the Kubernetes namespace. Although it actually is pooled, deployed in a Kubernetes cluster. As a second tenant onboards, you can actually create another dedicated namespace for this tenant. Namespaces in Kubernetes are very, it's actually there for isolation in a multi-tenant cluster. And it can help you actually do this type of silo deployment while you're sharing the same resources as you can see in the auto-scaling pool. It also comes with some services next to that. For instance, in the management part, you have CloudWatch for your metrics. You have Cognito for your user management. Services want to talk with each other, maybe asynchronously. So you have SNS and XQS for a queue and a PubSec mechanism. And you have various storages. For instance, RDS for your relational storage, DynamoDB for key value storage, or S3 for objects, and EFS for files. Sometimes actually, customers, they actually want to deploy their SaaS application in their on-premise environment, maybe for certain compliance requirements, or maybe they want to be closer in terms of latency. And it contradicts a bit with the SaaS, right? Because then the management somehow is out of the SaaS application scope. But with a solution like EKS Anywhere, which is an EKS that you can run on top of VMware, you can actually make the deployments on-premise, and it can still communicate back to your control plane, which is hosted in the cloud. It still needs be a little bit different in terms of provisioning, because on-premise you don't have services like RDS for your relational database. So you have to make sure that you provision a MySQL database, for instance, yourself. So the provisioning part in the control plane on-premise will be a bit different. But from a tenant perspective, if they choose for this option, they actually get deployed in an isolated namespace on that cluster. We also see customers, they actually have a more traditional application, web application, they got deployed. And they want to make a SaaS service out of that. For this, we have AWS Saas Boost. It's also open source, hosted on GitHub. And it's actually, it tells you to make that application inside a container, give it to the Saas Boost environment, and we make sure that it's like a SaaS type of experience. And with AWS Saas Boost, what it does, it provisions for you also the control plane using primarily Lambda. And the containers are run on ECS. And it has in the control plane things like onboarding, but also metric collection, user management, usage of quotas, which is important. And it integrates also with billing providers like Stripe. And it can already provide you analytic dashboards in terms of the metrics that comes out of your SaaS application, and really see the state of your business and your services. So I would like to end up with a couple of takeaways. So like Roma already said, there's actually no universal architecture for a SaaS application. You really have to think about what is more important for you. What type of model do I choose for this service? Is it siloed or is it pooled? And getting isolation right can be a challenge. You always have to think about things like security, manageability, but also the costs that come with that. So you're constantly choosing in those factors. And like we also said, automation is really key. Onboarding tenants to your application, you don't want to be at a manual process. So you want to invest in automation. And as your SaaS service is growing, you don't want to grow the team with you. You want to still make it easy for you to manage these type of environments. And it's good to actually evaluate the reference architectures like Saas Boost or SaaS Factory, because they can already give you a starting point into your journey with, towards a SaaS type of application. And also talk with your AWS solution architects. They're actually happy to work together with you, look at the challenges that you have and your business objectives, and they want to guide you in the process and the challenges that you have. There's also a SaaS Factory program for you to look at, which actually gives you some, not only on the technical side of running a SaaS business, but also on the business side. And actually, we now want to take a look from Jeroen with Showpad to see how they are applying SaaS and multi-tenancy at Showpad. So, Jeroen.
Thanks, Vincent. And hi, everyone. I am Jeroen. I'm going to spend the next couple of minutes giving you insights in how we architected a SaaS application at Showpad. So earlier in the presentation, both Vincent and Roma already highlighted the design principles that are articulated in the well-architected SaaS lens. In total, the SaaS lens has about 14 principles that facilitate good design for SaaS applications in the cloud. I'm going to highlight a couple of them and how we use these design principles at Showpad and how we've applied them. So let's kick things off with the very first one. There's no one-size-fits-all SaaS architecture. And there's no principle more true than this one. I think every business is unique and requires a unique architecture to solve its challenges, and Showpad is no different. So to give a bit of background, and for those people that attended the keynote, some repetition, Showpad is a revenue enablement platform. We've been enabling sellers for over 10 years. Today, we are serving about 1,200 customers in over 50 countries with a single open SaaS platform. That SaaS platform powers about 3.2 million buyer interactions and over 7.6 million guided selling experiences. And one quick side note from my side as well. So at Showpad, we consider a customer a tenant. So when I talk about a customer during this presentation, feel free to make that translation into the concept of a tenant. There we go. So since our founding in 2011, we've continuously innovated to meet those changing customer demands. We started off with a very simple iOS app that stood out at trade shows, and we continuously added new features on top of that over the years. For example, we brought products to life using AR and 3D. We introduced shared spaces to allow closer collaboration through buyer portals. About 2 years ago, we introduced Meeting IQ to leverage meeting intelligence, in particular to train and coach sales reps. And then last year, we introduced Showpad Video to personalize and streamline communication in the world of remote work. And all this innovation has a very distinct influence on your security, your reliability, your cost, your performance, and obviously your operational excellence. At the same time, it's very important to realize that you want all your tenants to be onboarded through and managed and operated through a single pane of glass. This is what ultimately allows you to achieve that agility and those economies of scale that make your business grow into a successful SaaS business. So the no one-size-fits-all principle doesn't only apply to the concept of your business, your SaaS business, it also applies to your SaaS customer. Each customer is unique and they come to you with unique use cases. And in all honesty, I must say it's very easy to get seduced in creating one-off versions of your product. However, the consequences that are related to such a one-off version, like maintenance and support, bring a lot of complexity with regards to, again, security, performance, cost, and especially your ability to provide operational excellence. Someone needs to put some batteries in this clicker. There we go. Solved. So in Showpad's case, customers are interested in solving unique business use cases that are concerned mostly around subjects such as content management, sales effectiveness, and buyer engagement. And for us, in order to prevent the creation of one-off versions, we use the concept of both features and pricing packages. So here you can see how we combine features into pricing packages. Showpad customers are able to choose between these different packages depending on their needs and their budget. And we can even go further and allow for custom pricing on a per feature basis. Now what's very important is that under the hood for us, these pricing packages are powered by our feature flag system. So our feature flag system is pretty fundamental at Showpad. It's pretty fundamental in creating tailored customer experiences. And the key here is that this feature flag management is automated. For example, it allows us to release features to customers automatically based on predetermined dates and requirements to allow for much smoother releases. It's important to note, however, that an automated feature flag system has a cultural impact. Everything we release at Showpad is feature flagged by default, and that means that our engineers need to take this into account as they develop new capabilities. But having such a system really does pay off for us. It allows us to easily change the composition of pricing packages without the need for engineering, allowing us to react very quickly to market trends and changes in customer demand. All right. So feature flags and pricing packages are constructs that prevent one-off versions of your product. They are determined by your business and your market demand. However, your customer's uniqueness goes beyond these individual features. And that's why it's very important to allow for global customization in your product. Customization in particular should be available to any customer, and it should be baked into your product experience. So with Showpad in particular, customers can heavily customize the product, as particularly for their brand and their marketing needs. And the next couple of slides, I'm going to show you a bit how we do that. So first of all, here you can see the different types of customization that are available to customers in Showpad. A lot of this is available through UI-based configuration so that it's easily accessible for non-technical users. However, for customers that really want that tailored experience, they have the option to build on top of our APIs and SDKs. And even for some customers that want to upload their 3D models, we can do that so that they can really bring their products to life. All right. The battery's really dead, I think. All right. So here's another slide that gives you an idea of the customizability of Showpad. Each of these 9 customizations provide a unique experience, but at the same time, it's powered by the same platform, the same code base, same developer lifecycle, same deploy process, and so on. So this is Showpad, just 9 times different for the customer, underneath exactly the same. All right. So as you saw in the last couple of slides, Showpad has experienced tremendous growth, and new features and a variety of customer use cases have driven Showpad to scale to new heights. And our ability to deal with consequent waves of new customers has only been possible because we've always designed and anticipated our software to grow. That said, that doesn't mean we had this all figured out from day one. Like over the last 10 years, our platform went through an enormous amount of change to accommodate our growth. So in 2011, we needed to provide a stable platform for both mobile and web clients to connect to. So in our case, that started with a traditional three-tier lab stack. So think about your PHP servers, MariaDB databases, and MooseFS for distributed file storage. There we go. So our biggest focus was on reliability, and that's why we introduced a lot of redundancy in this architecture, so that any increase in customer base was relatively easily handled by adding more servers. However, the challenge was that we were managing a lot of this infrastructure ourselves, leading to a lot of operational overhead for our engineering team. And that's why in 2015, we entered the cloud together with AWS. And at this stage, we mainly focused on a lift and shift of our on-premise infrastructure to the cloud. So we opted to deploy our application on a Kubernetes cluster that was supported by very basic AWS services like your EC2, S3, and CloudWatch, like you can see here. We, at this time, avoided tight coupling with AWS so that we can could put our focus on scaling the deployment of a very familiar application architecture. And in particular, containerization was a great strategy to achieve this. The big challenge here that we had during this period was that we were still managing a lot of this infrastructure ourselves, and a lot of this burden fell on a single team. So that team had a lot more freedom than before on one hand, but it also made them a much bigger bottleneck. All right. So in 2020, our engineering organization crossed the 100 engineer mark. At this point, the centralized infrastructure made it virtually impossible to further scale our organization. So we decided to phase out the central infrastructure management and started to direct that towards the individual teams. So by giving each of these teams their own AWS account, we were able to scale our infrastructure management more effectively. And combined with guiding principles, such as going in on serverless technology, teams were able to limit their overhead and keep their velocity to deliver. This slide in particular over here shows how from 2020 onwards, we started with a multi-account setup. So notice here on this slide how every single account has different services in them. We're giving teams with this a lot of freedom in choosing what service works best for their use case. However, teams are also instructed to limit their cost of ownership as much as possible. And as I mentioned in the keynote before, the result of the strategy is that today, Showpad is using about 80 AWS services. Again, those are the icons. You can count them. This is, by the way, 5 times more than 5 years ago, right? So like we really made a change in adopting AWS services and really made sure that all our teams could use that for their use case and could deliver on customer value. Once you're supporting more than 1,200 customers, it's obviously important to ensure that each of these customers is properly isolated. Any event whereby a customer can access data from another customer can mean the end for your SaaS business. And as such, it's always important to isolate all tenant resources. Yet, not every single service has the same multi-tenant load and isolation profile, nor does every single service have the same capability of isolation. So therefore, and Vincent already mentioned this in his slides, there are different strategies that are applicable, such as pooling, bridging, and siloing. This is also true for Showpad, and I'm going to give you 2 examples of how we do this, one being a silo model, the other being a pool model. So let's start with the silo model here on the left. Yeah. So you can see, for example, an illustration of how we isolate tenants on our Aurora cluster. If you want to get access to the data of a single tenant, for example, we first need to get the credentials of that tenant in our central database. This database acts as a registry for cross-tenant data. And once we have obtained these credentials, we can create a new authenticated connection to the database of our tenant. And with these tenants' credentials, we can only connect to that tenant database. That means that all the data of our tenant lives in a silo, so any query that tries to access data outside of this silo, outside of this database, fails. On the right-hand side, we have the example of a pool model. So here we are focusing on our OpenSearch cluster. OpenSearch is a typical service that doesn't work very well with a silo model because it would just require too much memory to be cost-effective, especially in Showpad's case. So at Showpad, data of multiple tenants is pooled together in a single OpenSearch index. If you want to access data for a particular tenant, you need to pass through a proxy. And that proxy takes an OpenSearch request, but also takes authorization. And using something like a JWT token for authorization, the proxy can extract that tenant context, modify the OpenSearch request to add an extra filter, and fire that off to OpenSearch to return with the results that you need. I want to zoom in a bit more on the challenges of the silo model. Yep. So the silo model is only viable for a certain number of services and comes with quite a number of challenges. So in our case, and in particular the case of relational database, we are dealing with more or less 2,000 tenants. And in practice, that means that if we request a single column change, we have to execute that column change over 2,000 databases, so it quite adds up. This forces us as a company to create extra tooling so that we could automate, but also throttle any column changes to our database. Another challenge here is schema drift. So we tried very hard to prevent things like schema drift from happening by carefully managing and automating schema changes. But after 10 years, you can imagine that a schema drift is unavoidable. You will at least, if you do this, occur some issues of schema drift due to things like partial schema updates and resurrected tenants. Finally, the silo model also makes it very challenging for business intelligence purposes. So one key use case for business intelligence is to get a global customer understanding. And this unfortunately requires data to be stitched together, which is not trivial. So that puts a heavy burden on your ETL process, especially keeping in that schema drift that I just mentioned. So right, once you've determined your isolation profile for your service, it's important to then limit developer awareness of tenancy concepts. Mistakes in code, as some of you might know, are easily made, and it's not always trivial and not always easy to test for. Once you've determined your isolation profile for your service, sorry, that was the same text. There we go. So one thing I still wanted to say is that Showpad has been very fortunate so far. Our architecture has helped us a lot in maintaining isolation. However, we have witnessed cases that passed our tenancy violation checks, such as automated testing and thorough code review. In the end, most tenancy issues were related to things like race conditions and then production-specific circumstances. We have a number of techniques to limit developer awareness and to ensure that developers can sleep peacefully at night. Firstly, we have a variety of libraries and frameworks that are maintained by a community of engineers. So more specifically, our cross-team guilds maintain these to ensure objective review and broad adoption. Secondly, we use configuration to ensure tenancy. So for example, we use services that allow you to configure header validation to ensure that HTTP requests are bound to a specific tenant. And then finally, on top of service, we build on top of service mechanisms. So I already showed you the example of where we use an authenticated MySQL connection to prevent cross-tenant access. But there's a lot more mechanisms that you can use. So for example, you can also configure queues and partition them per tenant. You can also make sure you can use different tables in DynamoDB, for example. The general rule of thumb for us is ensure that there's logical separation between your tenancy mechanism and your active code bases, so that no change in your active code base will change behavior in your tenancy mechanism. All right. So, in order to make tenant isolation work and in order to effectively limit developer awareness, it's important to bind your user identity to your tenant identity. Tenant identity, or to a larger extent, your tenant context, needs to be a first-class citizen. And you should always be aware for which tenant your workload is acting. On top of that, the authentication and authorization experience of your solution should bind a tenant identity to the identity of the authenticated user. So on this slide, you can see how we bind authenticated user identity to a tenant identity. First of all, every tenant in Showpad is characterized by a subdomain. So this unique attribute is available throughout the entire platform. And when entering Showpad via an HTTP request, we also identify the user using an OAuth bearer token, which is also unique across all tenants. Bless you. The combination of both that subdomain and an OAuth token provides double verification for a tenant. However, those subdomains and OAuth tokens are only valid in the context of an HTTP request, of course. There are other systems that don't use HTTP requests, so think about things like cron jobs. And so to ensure uniformity over our entire platform, we use something like JWT tokens to identify both the tenant and the user. You can see here on the slide how that happens for requests in Showpad. And notice in particular how we're using a central authentication service to limit developer awareness for this. And this brings me to the final principle that I want to highlight. So having uniform tenant context that is available everywhere isn't only used for tenant isolation, it's also important for your instrumentation and your monitoring. So you want to propagate tenant context in all instrumentation and monitoring systems so that you can pinpoint which tenants are putting load on your system and identify the cost profile of each of your tenants. So on this slide, you can see how we have implemented instrumentation at Showpad. On the left-hand side, you can see that we are using Datadog to give insights into the behavior of our tenants. We are currently capturing around 1,000 metrics that allow us to pinpoint issues the moment that they occur. And next to that, we are using CloudWatch for extensive logging. So where appropriate, our logs contain tenant context, which allows us to analyze which tenants are putting load on our system and what exact load they're causing. All right, so I hope you enjoyed this deep dive in how Showpad applies well-architected principles for SaaS. Feel free after this talk to come to me, ask questions, and I wish you an amazing rest of your day. Thank you.